Hello everyone, welcome back to another video of Statement List PLC programming. And in this video we talk about the edging instructions. To understand the need for edging, let's first look at this example. And in our example we have a start push button and a stop push button, both connected as digital inputs to our PLC. We also have a motor controlled by a digital output from the PLC. And we want to control that motor such that if the start button is pressed once, motor should start. And if the stop push button is pressed, the motor would stop. First, we say that any push button has two states, 0 and 1. And if you press, it will get closed and the signal state will become 1. And if you release it, signal state will go back to 0. Now we call the transition from 0 to 1 a positive edge. And similarly we call that second transition from 1 to 0 a negative edge. And we want to use this edge transition to control the motor. And for that we will use the FP instruction. To see how it works, let's look at this simple example. First, let's say that our input is connected to I1.0 and our output is connected to Q4.0. So first we will load the value of the input to the RLO using this basic and instruction. And then we want to have our edge instruction or the FP instruction, which should detect a change from 0 to 1 or a positive edge in the RLO. But for it to do that, it needs to know the previous value of the RLO from the previous program cycle. And for that, another address is used to keep that value, let's say M1.0. We call that address the edge flag. And let's debug that program. So we go to Online Block, choose Test Operation, and put our breakpoint here. And say now that we are at our first program cycle, and that our input signal was initially 0. So when we come back here, and execute our first instruction, RLO will be 0. And now the FP instruction will look at the previous value of the RLO in M1.0, which was 0, and compare it with the current value shown here, which is also 0. So no transition happened. So what it will do is store 0 in the address M1.0 and keep the RLO also at 0. And so here our output will become also 0. So that's our first cycle. Now let's go to our second cycle and assume that we change our input to 1. So if we execute that, our RLO will become 1. And the FP instruction now has current RLO of 1. And a previous value of 0 stored in M1.0. So positive transition from 0 to 1 happened. And what it will do now is first is update M1.0 to 1. And change the RLO to 1. Therefore after that our output will become 1. And that's it for our second cycle. So our input did become 1, causing M0.0, and our output to change to 1 is shown here. And we come to our third cycle. And here we assume that our input stayed 1. So RLO here will be 1. And the FP instruction will compare the RLO, which is 1, to the memory address, which also has 1. So no transition took place. and therefore the instruction will keep M0.0 as 1. And change the RLO to 0. And our output will become 0. And that's it for the third cycle. So basically what we conclude from that is that our transition which came in the second cycle did cause the output to change to 1 for only that one cycle. And if we follow the diagram, the same happens here. And also here. So that's how that instruction works. Now the FN instruction works the same way, but based on a negative transition. And if you look at this diagram, you will see that one negative transition should cause the output to become 1 for only that cycle, which is what we expect based on our previous discussions. Now let's implement our motor example. So we will first create an SR latch. Make our two inputs come from our two push buttons, and our output as the motor. We will add two FP instructions with M1.0 and 1.1. And let's monitor that example. And if you press the start button, you see motor starts. And it doesn't matter how long you keep it pressed, as motor will stay on even if it is released. And if you press the stop button, motor will stop. So how does that actually work? When you press the start push button, we change I1.0 from 0 to 1. Now this transition will cause the RLO after the first edging instruction, which is also our set input, to become 1 for that cycle. And with reset input at 0, set action will happen and the SR latch output will become 1. Therefore motor will start. Now after that cycle, set input will go back to 0. And with set and reset at 0, we are at the memory case and the motor will remain on until we press the stop button. If we now press the stop button, positive transition should take place. And it will cause the RLO after that second edging instruction, which is also our reset input, to become 1 for that cycle. And with set input at 0, reset action takes place and output becomes 0. Therefore motor stops. And after that cycle, reset input will go back to 0. And we go again to our memory case. Therefore motor will remain stopped until you start it again. So that's how to use edging instructions to control a motor. And with that said, we come to the end of our video. We have now finished discussing bit logic instructions. And in the next video we should move to the next section where we will discuss compare instructions. If you have any questions, please post them in the comments. And please like and subscribe to the channel.